Hi everyone, I am JULKA. Today in Indefinite Integral Part 9, we'll talk about how to integrate tan and cot functions. Integration of tan x respect to x is minus log in mod cos x plus c or log in mod sec x plus c. Integration of cot x respect to x is log in mod sin x plus c or minus log in mod cosecant x plus c. So first we prove the formula of tan x dx. We can write tan x as sin x upon cos x. Derivative denominator present in numerator, so put cos x equals to t, differentiate respect to x both sides, so minus sin x equals to dt by dx. Replace minus sin x dx with dt and cos x by t. Integration of 1 by t is log mod t plus c and replace t by cos x. So answer is minus log mod cos x. N log m is log m raised to power n. So minus log cos x equals to log cos x raised to power minus 1, which is equals to log sec x plus c. Now integration of cot x. Replace cot x by cos x upon sin x. Derivative of denominator present in numerator, so put sin x equals to t, differentiate respect to x both sides, and we will get cos x equals to dt by dx. So cos x dx replaced by dt and sin x replaced by t, and the integration of 1 by t is log mod t plus c. Put the value of t equal to sin x. The answer is log in mod sin x plus c. Next point, whenever we have tan square x replaced by sec square x minus 1, and whenever we have cot square x replaced by cosecant square x minus 1. We have one example. Integrate 2 tan x plus 3 cot x whole square. First, expand 4 tan square x plus 9 cot square x plus 12 tan x into cot x. And 10 cancelled by cot, so it is only 12. Now tan square x replaced by sec square x minus 1. Cot square x replaced by cosecant square x minus 1, and after simplification we will get 4 sec square x minus 4 plus 9 cosecant square x minus 9 plus 12, and it's equals to 4 sec square x plus 9 cosecant square x minus 1. Integration of sec square x 10x, and integration of cosecant square x is minus cot x, and the integration of 1 is x. So answer is 4 tan x minus 9 cot x minus x plus c. Next point, whenever we have tan raised to the power mx or tan raised to the power nx or cot raised to the power mx or cot raised to the power nx, where m is even and n is odd power, put tan x or cot x equals to t, then divide and solve. For example, tan raised to the power 4x. Put tan x equals to t. Differentiate respect to x both sides. Sec square x equals to dt by dx. So dx equals to dt upon sec square x, which is equals to 1 plus tan square x, and replace tan x by t. So dt upon 1 plus t square equals to dx. So tan x replaced by t and dx replaced by dt upon 1 plus t square. Now divide this fraction. After division we will get t square minus 1 plus 1 divided by 1 plus t square. This is quotient plus remainder upon divisor. Integration of t square is t cube by 3. Integration of 1 is t, and the integration of 1 upon 1 plus t square is tan inverse t. Replace t by tan x, and the answer is tan cube x upon 3 minus tan x plus c. Next example, cot cube x dx. Put cot x equals to t. Differentiate respect to x both sides. So derivative of cot is minus cosecant square x equals to dt by dx. So dx equals to minus dt upon cosecant square x, which is equals to 1 plus cot square x. Now replace cot x by t. So it is dx equals to minus dt upon 1 plus t square. Cot x replaced by t. T cube divided by 1 plus t square into minus dt. Now the power of numerator greater by the power of denominator, so divide this. After division we will get t minus t divided by 1 plus t square dt with a negative sign. Now, if we separate this is minus t dt plus t divided by 1 plus t square dt. Derivative denominator is 2t in the second part. So, divide by 2 and multiply by 2. And the integration of first part is t square by 2. So, after simplification, we get minus t square by 2 plus 1 by 2 log in mod 1 plus t square, because the derivative denominator is present in the numerator. The answer is log denominator. Replace t by cot x. The answer is minus cot square x by 2 plus half log in mod 1 plus cot square x plus c. Next point. Whenever we have a question of dx divided by 1 plus minus tan x or dx divided by 1 plus minus cot x. So first convert into sin and cos and then solve. First question, dx divided by 1 plus tan x. First we convert into sin and cos. So this is equals to dx divided by 1 plus sin x upon cos x. After taking LCM, it will be cos x dx divided by cos x plus sin x. Now divide by 2 and multiply by 2. Now in numerator we have 2 cos x. We can write 2 cos x as cos x plus sin x plus cos x minus sin x, and the whole divided by cos x plus sin x. Now divide into 2 parts. This is 1 by 2 cos x plus sin x divided by cos x plus sin x dx, and the next part is 1 by 2 cos x minus sin x divided by cos x plus sin x. First part cos x plus sin x will cancel by cos x plus sin x. So integration of 1 is x, so it is x by 2 plus second part half log in mod cos x plus sin x plus c, because the derivative denominator present in numerator. So the answer is log denominator. Next question. Root 10x dx divided by sin x cos x. Whenever in question of integration we have root in above, first rationalize and solve. So multiply numerator and denominator both by root 10x. And we will get 10x divided by sin x cos x into root 10x. In numerator, we can write 10x as sin x upon cos x. So it is sin x divided by sin x cos square x into root 10x. Sin x cancelled by sin x. 1 upon cos square x is sec square x divided by root 10x. Now put 10x equals to t. Differentiate respect to x both side. It is sec square x equals to dt by dx. So sec square x dx equals to dt, and put 10x equals to t. So integration of dt upon root t is 2 root t, and the value t is 10x. So answer is 2 root 10x plus c. Next point. Whenever we have a question dx divided by sin x minus a into sin x minus b, or dx divided by cos x minus a cos x minus b, first divide and multiply by sin b minus a. In numerator, break sin b minus a as sin in angle x minus a minus x minus b. Then expand and solve. But if in a question we have dx divided by sin x minus a into cos x minus b, or dx divided by cos x minus a into sin x minus b, then first divide and multiply by cos b minus a. In numerator, break as cos in angle x minus a minus x minus b. Then expand and solve. Next example. Dx divided by sin x minus a into sin x minus b. First we divide and multiply by sin b minus a. So we take 1 upon sin b minus a outside, and in numerator we take sin b minus a dx divided by sin x minus a into sin x minus b. In numerator sin b minus a, we can write sin b minus a as sin x minus a minus of x minus b dx divided by sin x minus a sin x minus b. We know the formula of sin a minus b. It is sin a cos b minus cos is sin b. So in numerator we have sin x minus a into cos x minus b minus cos x minus a sin x minus b, whole divided by sin x minus a into sin x minus b. When we divide into 2 parts, then we have 1 upon sine b minus a outside, and the first part we have integration of cot x minus b. In the next part we have integration of cot x minus a. Integration of cot is log mod sine x. So we have 1 upon sine b minus a outside, log in mod sine x minus b minus log in mod sine x minus a. Log m minus log n is log m upon n. So the answer is 1 upon sine b minus a log in mod sine x minus b divided by sine x minus a plus c. Last example, dx divided by cos x minus a into sine x minus b is a combination of cos and sine. So we divide and multiply by cos b minus a. Now we have 1 upon cos b minus a outside, and it's the integration of cos b minus a dx divided by cos x minus a into sine x minus b. Now we break numerator as cos in angle x minus a minus x minus b. We know the formula of cos a minus b is cos a cos b plus sin a sin b. So it's equals to 1 upon cos b minus a into cos x minus a into x minus b plus sin x minus a into sin x minus b. Now take cos x minus a and sin x minus b in the denominator of the both. Cos x minus a cancelled by cos x minus a and sin x minus b cancelled by sin x minus b. Now when we go for the integration, it is 1 upon cos b minus a log in mod sin x minus b minus log in mod cos x minus a plus c. Log m minus log n is log m upon n, so the answer is 1 upon cos b minus a log in mod sin x minus b divided by cos x minus a plus c.